for GATE till date with the best of the questions by best educators with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello friends, welcome to Unacademy, which is the largest online education platform for GATE computer science and information technology. Myself Malesham Devasane. In this session, I'll be discussing a GATE year 2014, possibly a GATE 2013 also. Detailed solutions for every question will be discussed in this session. Okay, before starting this session, let me introduce myself if anybody is new to this session. Okay, you will be knowing about me, that is, my name is Malesham Devasane. I'm working as an educator on Unacademy. I teach in GATE and ESE segment where computer science and IT, I'm going to take the subjects like C programming, TOC, compiler, discrete maths, algorithms, various subjects I may take on this platform. And I have almost 12 years of teaching experience and taking the GATE classes. I have completed MTech from IIT Bombay in the past, and I worked at various institutes in India to train the GATE aspirants. In case if you want to attend my free classes and if you want to watch recorded sessions on Unacademy, follow www.unacademy.com/devagatecsc. Use this URL to access all my free classes. More than 400 classes are accessible freely on Unacademy. So you can visit URL and access all my free classes. In case you need any referral code, you can use this referral code to access the free classes. Also, if you want to take the subscription, the 10% of an Unacademy Plus or Iconic subscription with this referral code. Yeah, if you want to use the app from Unacademy, you can go to Play Store, search for Unacademy Learning App and install, and right away you can use you can listen all classes from Unacademy. Okay, what are the benefits you will have if you are going to use Unacademy, or if you are visiting Unacademy for learning computer science subjects? You will learn the concepts from India's top educators. If you see that, you are accessible to all the free classes, as well as you can enroll for the Plus or Iconic if you are enjoying. And what are the benefits of the Plus or Iconic? We have two kinds of subscriptions on Unacademy: Plus, Iconic. So if you want to go for Plus, you will have live interactive classes, and along with that you have so many batches. All the batches you can attend, and you can follow any batch that you are interested. And every course, every subject, that we will have weekly test and doubt solving sessions, and you can learn the concepts both in English and Hindi. You can ask the doubts in any language mode. And these are the benefits of Plus. You will have a structured courses, you will have well planned courses, you will have top educators in every course. That is going to be beneficial for Plus. Iconic, all the benefits of Plus. Additionally, you will be having dedicated coach, you will be having separate material and study plan, booster sessions, separate test analysis, many benefits for the Iconic too. And how do you access to our free classes? You visit unacademy.com, choose the goal, GATE and ESE. In case if you have not logged in, log in first. In case you need a referral code, you can use this referral code. You can use this referral code to access the free classes and search interested course, or you can go for subscription. And here you will have a Plus or Iconic. You can choose any plan as per your requirement. And in case if you want to take the Plus subscription, then you have many plans like 1 month, 3 months, 6 months, 1 year, 1.5 year, 2 years. And among them, popularity is for 1 year, 1.5 year, 2 years, where you will get a lot of benefits to access the courses. And here you will have 1, 1.5, 2 year price plans, and use referral code in case you want discount. Yeah, Iconic, you have very popular plans like 1 year, 2 years. Here you can see 1 year 45,225, 2 years 66,600, and after using referral code. Okay, the Unacademy started recently new batches where from 21st December GATE Electronics Electrical, and from 28th December Mechanical Civil batches started, guys. And GATE CS and IT will be started soon, and we will be announcing whenever the batch comes. And it's a time to start our class. In case if you are watching this video, please like this session. And here we are going to start with the 2014 first, then we will look at 2013 based on our remaining time. And first let's look at GATE 2014. Let's look at the explanation. Answer is C, no doubt. You can see in every slide answer is also there. But it's not about the answer, it's about the concept of why did you get that answer C. Maybe other answers might be right, we should check carefully. L is a language and L complement is another language. Which of the following is not possible? Viable possibility. Which of the following is not possible? Okay. Neither L nor L complement is RL. Means is trying to say L is not RL and L complement is not RL. Is it not possible? It is possible, guys. This statement is possible. It is possible because some of the not RL, their complement also not RL. It is possible. You want not possibility. Right, option A we will not choose because it is possible. One of L and L complement is RE and RE but not recursive, other is not RE. It is possible. If L is RE but not recursive, L complement definitely is not RE. It's trying to say the same thing. One of them is RE but not recursive, other is not RE. It's not just possible. It is always true. It is always true. If one of them is RE but not recursive, other has to be not RE. Yeah, this is possible. See, both L and L complement RE but not recursive. Guys, it is impossible. L is trying to say RE but not recursive and L complement is also same. Both never be in the same class, guys. If L is RE but not recursive, L complement definitely outside. Remember that. This is impossible. Both L and L complement never be inside RE but not recursive class. Remember. That is impossible. Exactly. They want not possible only. Okay, we have chosen it. Both are recursive. L and L complement, yes. L and L complement are recursive. Both are possible. Yes or no? Yes. So we don't choose that. Okay, let's go to the next one. A reducible to B denotes the language mapping reducible to another language. So this is A is reducible to B. And which of the following is false? There could be so many true statements. We have to choose it. Let's start. Don't worry about this. Is already given, right? Only you should look at that. B is recursive. If B is recursive, like whole project is recursive and every module inside is recursive, obviously recursive. This is a true. Right. If A is undecidable and A is undecidable, B is undecidable. If module is undecidable, that means module has no halting Turing motion, then project also. Yes. So this is also true. And B is REL, then A is also REL because B has a Turing motion, A should also has a Turing motion because A is the smaller or less order than the B. So this is also true. And now B is not REL. That doesn't mean that A is not REL. Is that true? B is not REL. A might be REL, guys. A might be not REL. You don't know. What you are trying to say, B has no Turing motion. but A might have, right? B is not real because of there may be other reason inside the B. Yes, D is the false statement. Fine. Next one. Which of the following regular expressions given below represent the following DFA? And now you should be very careful to understand this problem. Let me keep this A, B. And B is the final state. And all the strings ends at B, it just ends with one problem, right? You can see that ends with one. Ends with one. Yeah, it ends with one. So can you identify which are equivalent to this ends with one? And most of you know ends with one problem. You have very simple expression like 0 plus 1 whole star 1. But did they ask that? Okay, in one of the option it is there, that's good. But 3 is only not exist in these options. You have other options also, right? Let's look at. Yeah, it's a 1. This is the first point, guys. Yeah, try ends with 1. Try ends with 1. Let's take this one. Statement 1. 0 star 1. 1 plus 0 0 star 1 whole star. Is it ends with 1? Just try, guys. Take the 1 right side common. So here you will see epsilon plus 0 plus. Because 0 0 star is 0 plus. And you know this is equal to 0 star. 0 star 1, 0 star 1 whole star. And this is equal to 0 star 1 whole plus. You know that there is another difficult form of expression which is 0 star 1 whole plus. This is also ends with 1. All the strings ends with 1 are covered. Yeah, thank you, Amarinder. Everybody, 0 star 1 whole plus. This represent 0 star 1 whole plus. And we have seen in our regular class, this is also ends with 1. And this one, if you look at, is it covered? Every string ends with 1. Look at that, guys. Ends with 1. Is that every string covered? Try it, guys. Try. Suppose if I have a 1 0, I'm trying here, but I'm trying to fail it. 1 0 1 1. That's impossible here. Look at that. It ends with double 1. So this 2 is not equivalent to our ends with 1 problem. So 1 and 3 are correct. I'm trying to give you a counter example. There is no string, there is no way to generate 1 0 1 1. That ends with 1, but it is not covering. Yeah. Fine. So first and third statements are right. Let's move on to the next one. The length of the shortest string. Shortest, remember, they never ask maximum, longest. Remember that. The length of the shortest string that is not in the language. That means there might be possibility of 0 length, 1 length, 2 length, right? You need to try like that. So I'm just writing just to have a clarity, guys. Epsilon, A, B, double A, B, B, A, B, B, and so on, so on. I'm going to verify one by one very quickly because you need a shortest. There might be possible 0 length is not there. So you need to try, is that 0, 1, 2, 3, 4. This order we need to try so that you will get a shortest one, which is not in the language, remember. Epsilon, is it there in the language? Yes. A power 0, B power 0, B A power 0. Yes, epsilon possible. And what about A? Possible, because you can keep A power 1 remaining, or epsilon you can keep. Possible. B, what about epsilon, B power 1 remaining, or epsilons? Possible. Like double A possible. You can see that A square is there. Remaining you can put epsilon. Yes, possible. Like AB, possible. A power 1, B power 1 remaining epsilon. BA, yes, possible. You can write BA here, remaining or epsilon. Possible. BB, yes, B square you have here. Many other ways too sometimes. Possible. Now you have to try. Up to 2 length are exist. Yes or no? Exist. Now you have to try 3. 3, there are so many strings, guys. but in a simple way you can just try in a sequence so that you will get somebody quickly. Triple A exists because of you can write a power 3 first. AAB you can write A B A also there. ABB is there. B double A is there. BAB. BAB. This is not there. First string, guys. You can try that. You know, BA is here. B is not possible because if you come back, A again comes. If you take B here, A is here. There is no other B. So if you try BAB from this expression, not there. So first 3 length string, that is not possible in this language. Yeah. Everyone? Come on, come on. Yeah, this is how you compute. This is how you compute. Let's move on. Next one. Consider the alphabet. Sigma is equal 0, 1. The null string epsilon and the set of the strings x0, x1 and x2 generated by the corresponding non-terminals of regular grammar x0, x1 and x2 are related as follows. So he is trying to give a regular grammar but in terms of equation. Yeah. Rick, thank you. And also worst is also best. Remember that. Yeah, clear? Thank you so much. I feel, very proud when you comment either like or dislike. And it's clearly visible who are disliking these videos. Yeah. Thank you. X0 looks like this is in general a grammar, guys. He's already giving as a regular grammar. It's a right linear grammar. X2, 0, x1 or epsilon. He has represented in the form of equation. Okay. Now what we have to find, which one of the following, is not x. Which one of the following choices precisely represents the strings in x0? Means what is the language generated by x0? That is the meaning. Everyone, so let's try from bottom to up because x0 is a start symbol here. So what is x2, guys? x2. What is x2? Oh. You can't write. So just assume it is same. It is same 0, x1 or e. And assume this is the first one. Take it and substitute. Substitute in x1. What is x1? 0, x1. So let me write first production. Then I will prove it. What is x1? x1, 0, x1, x2 substitute here because we have already assumed we have computed. So what I am going to do? 0, x1 plus e, epsilon. Then what x1 grammar looks like, production looks like 1, 0, x1 or 1 epsilon is 1. Yeah. Now we have converted everything into x1. Now you know how to write an equation. 0 or 1, 0 whole star and 1. Everybody? This is language of x1, but we want language of x0. So what we do here, and we take x1 and x2 both. If you want x2 again, this x1 you put in x2, but again we don't want x2. So x0 is just 1 x1. X1 we just computed, just put here. Yeah, if you look at the options, everybody see that which one is matching? C is exactly matching, you can see that. But sometimes multiple options can be correct, be careful. Nobody should represent the same language again. Right, everyone? Yeah, there could be multiple answers possible sometimes. Yeah, great. Sometimes people might come up with a different answer like 0 star, 1 0 whole star 1. That is also right, guys. Because a plus b whole star, you can write a star b star whole star. They may write. So you should be very careful. Yeah. If it is MSQ, there could be multiple answers for the same language. Great. Next one. Which one of the following is true? Which one of the following is true? Now here regular, they are trying to say everything is regular, and we need to find out who is actual regular. A power n, B power n. It is actually non-regular. You know that. It is a false. And A power prime is also non-regular, but they are saying regular. And next one, W has 3k plus 1 b's for some k belongs to n, and you know that number of b's is equal to 1 mod 3. 1 mod 3 guys. That is regular. It is true. It is true. Everyone, and this one, there is a dependency between the symbols of the string with WW, right? Yes, it is non-regular, so it is also false. Only C is true because in C, the number of b's is equal to the 1 modulo 3. When you divide with 3, you will get a remainder 1. And that is regular. Obviously, take 3 states if you include epsilon. If you, so epsilon is also not required. Yes, it just takes 3 states, guys. Just takes 3 days, 3 states. Okay, next one. Yeah, some things will be duplicated sometimes. Just ignore it. Yeah. L1 dot L2. L1 is A power n. L2 is B power n. Guys, this A power n nothing but A star only. B power n nothing but B star. If you say L1 dot L2, if you want to write in terms of n, you can't use the same power for both. You have to change as n1, n2. That's fine. That's fine. n1 greater than or equal 0, n2 greater than or equal 0. Because both of them you can't keep n when you concatenate, because if you keep the same power, then they will be related. Otherwise, you can write A star dot B star. But anyhow, it is regular. L1 dot L2 is regular. It is the correct. But you can't write this way. This is wrong. A power n1, B power n1 you should write, n2 you should write. But you can't take A power, B power, same guys. Because even though two are different languages, they have two different powers. When you concatenate, they should have a different powers. But unfortunately, what we do sometimes, here we represent n, here also we represent n. But when you concatenate, we have to think a different n. Yeah, that is how we should concatenate. Yeah, good evening, Preet. Good evening. Yeah. Next. Only one is correct. Yeah. And this is, I can put 3 star. It's not easy to explain in 1 line or 1 minute, but I can give you one trick about it. When you are comparing the occurrences of 110 and 011, you can look at the pattern. 110 reverses 011. That means this pattern we can remember, because if you are writing, look at occurrences 110 followed by 110. If you are counting 110 twice, 011 happened. So actually no need to remember the only 110. When you are remembering 110, automatically 011 also included in the count. That means you can check the count of 110 and 011. Both of them you can check. Hardly they differed by 1. They differed by 1, guys. They differed by 1. If you get 110, there is no 011, but there is 110. And similarly, 011 when I am trying to write twice, but automatically 110 happened. So in the first pattern, the count automatically happens. The number of 110s, the difference always equal to the number of, okay, let me write some other way. Here there are 2 languages, guys. First I am talking about L1. Here the number of 110s, is equal to number of 011s may happen, case 1, And case 2, number of 1 zeros is equal number of 0 plus 1. It could happen. And third one, number of 0 equal number of 1 plus 1. Everybody, these are the only 3 cases in the world. Can you try 110? There is one more 110 without 0 impossible guys. So you are going to remember only 3 things, and that is how the first language is regular. They want to just say regular. They are not asking to design a machine. If you want to design a machine, it will take time. That's why we don't design a machine. And that is for L1. What is L2? And now you need to remember 00011 guys. And how can you compare 00011? There is no relation between them. 000 can come any. Here how many 000s are there? 1, 2, 3, 4, 5, 6, 7. 7 000s are there. And that can come 1 lakh. To remember them, you need nearly 1 lakh states. And that's not possible to remember. So this is not regular basically. L2 is not regular. It is one of the difficult concept. I have designed machines for this language in regular classes or in practice classes on Unacademy guys. Okay, this L1 is regular, L2 is not regular. I have shown I have kept a name as pattern based. So many patterns I have explained in the class. So you can watch that video if you are interested. It's not just this 110011 guys. I have shown many examples. Okay. Now this is about 2014 and 2013 next. Okay. Which of the following is false? For every NTM there exists equivalent DTM. Yes, because we can convert every NTM to DTM like NFA to DFA. This is correct. This is true. For every NTM there is a DTM. We know DTM is equivalent to NTM. And second, Turing recognizable means RE recursively enumerable languages are closed under union. This is true. But complement, this is false. Because REL complement need not be REL. We know that. Right? Yeah. So this is the false statement. Turing decidable means decidable languages. Recursive languages are closed under intersection complement. Both are correct. So this is a true statement. True. Even first statement was a true. Right. Fourth one. Turing recognizable means RELs, recursively enumerable languages, are closed under union intersection. This is also true. Only the second statement is a false guys. Yeah. Okay, next. Which of the following are undecidable? And this is emptiness problem guys. You can see that. We are checking for language generated by grammar is empty. Emptiness problem for CFLs. Push down automata, context free grammar. All of them this problem same. Right, you are talking about CFL indirectly. This emptiness problem is decidable how? You take a CFG and you simplify it. You will get simplified CFG and check is it empty or not. At least one production is there. It is non-empty. No production left. All productions are deleted. Means language is pi. At least one production left. That is non-empty. Otherwise non-empty. Clear? Yeah. Decidable. This is a decidable. They want undecidable guys. So we'll delete this. And this is a totality problem. Totality problem decidable only for DCFLs and regulars. We know that. This is undecidable. Undecidable. And it is given Turing machine accepting regular language. There is no way to prove. Undecidable. It's also not just undecidable, it is also not REL guys. and DFA NFA are given to you. DFA and NFA, that is A and this is N, and languages accepted by these two machines. You can convert to minimum DFA, you can convert to minimum DFA, you can check that are they isomorphic or not. You can check are they accepting same language or not. Yes, this is decidable, guys, but we need to choose undecidable, so we don't choose this. So 2 and 3, that is answer D. Yeah, good evening Nikhil, good evening. All right. Okay, now let's move on to the next problem. Which one of the following problems is undecidable? Now we need to choose again undecidable. Undecidable, decidable questions are so easy, guys. Problem is inside undecidable, if they ask partially decidable or not, then you must be careful. Okay, these questions are very easy. Deciding if a given context-free grammar is ambiguous is undecidable, no doubt, because there is no algorithm to check, there is no algorithm to prove, right? There is no algorithm to exist to check ambiguous and unambiguous. And if a given string generated by given CFG, this is a membership problem. Membership problem is decidable, you know it. CYK algorithm exists. So far A is only right answer. Now we are looking at C. Deciding if the language generated by given CFG is empty is emptiness problem, guys. You can do simplification, you can check. This is also decidable. And deciding if a given language if language generated by given CFG is finite, it is a finiteness. That means given CFL finite or not indirectly. Right? B, C, D are decidable, but A is undecidable. Yeah, A correct. Okay, now we have a DFA. It's a given to you. I don't know what they are going to ask. We need to look at which of the following statements are false. And let's try what are the statements they have given. A complement of LA is context free. Complement of LA is context free. I think this is a 1. And L of A is equal to, this is a 2, the number is missing, and this is the 3 and 4. There are 4 statements, guys. So first is complement of L of A is a context free, guys. First L of this machine is, we know, regular, because finite automata is there, then complement has to be regular, no doubt about it. If it is regular, you can say CFL. So statement 1 definitely true. I'm writing here statement 1 definitely true. And statement 2, language of A, we should take time because they are asking about language, which will really take time. We'll see that. 2, I'm leaving it right now. 3, for the language accepted by A is minimum DFA. Is it minimum DFA, guys? Oh, it's not minimum DFA. You can combine these two. If you apply the algorithm, you will know that. The capital A, capital PQR, let's say. P and Q you can still combine. P and Q can be combined. Into one state. You can design like this. PQ self loop on 1 and on 0. On 0 you can go to final state R. You can design like this. That means the given machine is not a minimum. So 3 is the false. We got the 3 answer. Now we have to choose 2 or 4. We need to find out. A accepts all strings over 0, 1 of length at least 2, guys. At least 2. Wrong, because here you can see that single 0 accepted here. You can see that single 0 is there already in the language. So this is a false. You can easily choose that 3 and 4 are false, but only that statement 2 you have to prove true. Anyhow, I'm going to prove that. Statement 2, guys. Statement 2, I'm going to prove that true. Okay, this is a statement 2, guys. This is a 2, statement 2. Yeah. What is statement 2? Language is given as, there's a 1 1 star 0 plus 0 followed by 0 plus 1 whole star 0 star 1 star. Okay, now is it correct language? Look at that. look at that, this is completely 0 1 star, 1 1 star 0 plus 0. This can I write 0 plus 1 whole star? This whole thing, because 0 star 1 star I can put epsilon, I can get always 0 plus 1 whole star. Now can I take a 0 common right side? Take 0 common. What do you see here? 1 plus 1 1 star plus epsilon, followed by 0 plus 1 whole star. Everybody, otherwise you can also look at here, you can understand. Simplifying also I can do. I don't need to do that. If you can understand, look at 1 1 star 0 or 0. If you want to go to the final, 1 1 star 0 or directly 0. That is only we are talking about, followed by anything. Exactly, the machine represent the same expression, guys. So 2 is also true. 1 and 2 are true and 3 and 4 are false. Yes. Everyone, we need to choose the true. Remember that. Okay. Yeah. Okay, next question. This is a very popular question, guys, in machine. Consider the finite automata. This is the given finite automata. NFA, DFA doesn't matter. The set of reachable states for the input string 0011, and reachable states means by default they are talking from initial state. It's nothing but from initial state. By reading 0011, what are these states you get here? That means from Q0, by reading 0011 string, what are the states you can halt? There could be more paths, that every path can halt at a different state. So you have to work on. So one by one. See guys, Q0 there is a self loop 0, 1. So somebody can prove that I can halt at Q0. Yes or no? I can read everything, whatever you give. I can read from Q0. I can halt at Q0. You can halt it. But don't worry about accepted or not accepted. They didn't ask it. Is it accepted or not? They asked only about reachable states. What are the states that you can halt at? Everybody? Fine. Now, from Q0. Yeah, from Q0. Now let's look at another one. Is it possible to halt at Q1? Yes. Here from Q0, by reading 1, I can also go to Q1, I can halt. Right, I got so far Q0, Q1. I am trying for now Q2. Is it possible to halt at Q2? Look at that, guys. From Q0, by reading 1, I can go to Q1, and next one I can go to Q2. Yes, Q2 also I can halt. No, Q3 can I halt? Try it, guys. Q3, look at this one. Here 1 is there, and to reach here 2 length. Minimum 2 length, guys. Total I have 4 length. But this is 0 is there. Right? If this is 0 is there. If you have a 0, there is a chance. But you don't have a 0 here. You have a 1. How can I go to final? That Q3 is not possible here. You try, read 0011 from Q0. 0011. It's not possible to reach to the Q3. Remember. Yeah. Q0, Q1, Q2 only. It's not possible to reach this state by reading 0011. Do whatever. You don't have a path to the Q3 from Q0 by reading 0011. Yes. Next. Come on, guys. Now, let M be the encoding of a Turing machine as a string over sigma 0, 1. Let, see, machine is a string, guys, here. And we need to collect the set of machines, means set of strings. Like M1, M2. This is M1 and M2 and M3. What this machines does? then accepts a string of length 2014. String of length 2014. Which string doesn't matter. Some string. Everyone, now it's just membership problem, guys. Every motion just apply membership or non-emptiness. Very simple. You can reduce to membership. You have only few 2014 length strings. You can apply one by one, so that if any string accepted, that motion will alt at final. But if nobody accepts, that's okay. See here, if you are looking at one problem at a time, guys, whether, now here you should be very careful. You need to look at carefully, is it recursively enumerable or not. They are asking about that too. So I'm trying to find out whether TM accepts some string is enough to prove it. This problem is going to give the solution for this problem too, that some string are only 2014 length strings. So what do? The sum string, already we know that membership problem. Even this problem reducible to membership too, non-emptiness. Now S means, okay, there is some string of 2014 length exists. Definitely some Turing motion means you can copy Turing motion many times. Every string you can copy one Turing motion. If any Turing motion halts at final, then yes, you have a logic for that. But if all Turing motions never halts, you will not have a logic. You can understand by definition, the S only will have a logic when the Turing motion accepts some string of 2014 length. If no string accepted, even every Turing motion can go to infinite loop. You will never understand. So this is undecidable, no doubt, but it is partially decidable. That is RG, but not recursive, guys. One problem is RE but not recursive. The same problem you can use for this entire language. For every motion, separate, not algorithm, separate logic. It's not algorithm, it's a logic. Fine. It is undecidable but recursively enumerable. You can't say decidable. If it is decidable, I can say recursively enumerable. But you don't have a logic for no. Because L complement, there is no logic. You can understand. Yeah. This slightly, as I told, the definitions are very important for the last chapter. Yeah. Why we don't choose option C? It is undecidable, correct. But they are saying S has no logic, but S we have a logic. Option D, decidable, is wrong because no, we don't have a logic. Okay, only B is the right answer. Yeah. Next one. And how do you understand this one? 0 star, 1 star, R star. Sorry, 0 star again. They want about context free. Obviously it is regular, so can I say CFL? True. It is CFL and it is also regular, no doubt. Next one, P not equal to R, guys. It is basically DCFL. Only P and R you need to check, right? P less than R, P greater than R. You can do that using DPDA. Yes, DCFL, so CFL. Now they want false. L2 is context free. Is it false or true? It is true. It is true. And intersection, guys. When you apply the intersection of both of them, you will get L1 intersection L2. You will get L2 only. Because L2 is inside L1, guys. Here L2 makes a relationship with L1 and L2, this language is inside L1. Okay, so it is also true because L2 is already CFL. And they want false, remember. Complement of L2, this is CFL, right? DCFL, it is DCFL. Complement is again DCFL, no doubt. L2 complement is DCFL because DCFL complement is DCFL, guys. And obviously it is recursive. It is a true. And complement of L1 is a context free. That's correct. But they are saying not regular. If L1 is regular, L1 complement has to be regular. But they are saying not regular. That is why we are not choosing option D. Right? We are not saying that is true. It is false. This is only the false statement. take time and do it quickly, guys. What is this language? Are they talking about DCFLs? Yes, they are talking about DCFL. So focus on DCFL. So it is DCFL because you can push zeros and you can pop zeros for everyone. And C is there to differentiate. So before C, push everything, after C, pop by match. And it is a DCFL. And we know this is a well-known language for CFL, but not DCFL. We don't have a DPDA for that. And now just you need to choose, guys, which of these languages are DCFL. Did you see that L1, L2 are DCFLs, but L3 is not. Only L1, L2 are DCFLs, but not L3. Yes, very easy, very easy. If you already studied the TOC, just by looking at this problem, you can answer it. But you need to practice, you need to understand why L3 is not a DCFL. Okay. This is out of syllabus today, but still you just try to understand. The problem of determining whether there exists a cycle in undirected graph is in P, because this can be done in order of n time. If n is your number of nodes in the graph, you can use BFS, DFS to find a cycle in the graph. To find a cycle in the graph, it takes polynomial time, so it is a P problem, no doubt. So it is in P class. It is in P class. This is a true, guys. A problem of determining whether there exists a cycle in undirected graph is NP. It is already P, so definitely NP, definitely NP. And if a problem is NP complete, there exists a non-deterministic polynomial time algorithm to solve A. That is true. NP complete problem means you have NTM. You have NTM to solve. NTM can solve in polynomial time. NTM solves in polynomial time, guys. That is the definition of NP problems. In that, NP complete is one of the special problem. Polynomial time. So this is also true, so we choose A. But anyhow, so be careful, it is out of syllabus today. So if you don't study, it's fine. But if you want to learn about this problem's definitions carefully. Okay. L1 is phi, L2 is A. Very simple language. L1 is pi, L2 is just A. Now what they are trying to say? L1 means pi dot L2 is A and all star union L1 star, that is a pi star. And you know, the pi dot anything is pi union, but pi star everybody should know that is epsilon, because pi star means you will have pi power 0 union pi power 1 union pi power 2 and so on. But pi power 0, anything power 0 is epsilon, guys. Remaining are pi, but this result is going to be epsilon. So pi union epsilon is epsilon. Clear? Yeah. Fine, guys. It's very easy, very easy. Yeah, I think you have understood the 2-year questions. But if you feel any questions difficult, and you should catch me somewhere on Unacademy free classes and ask me about each and every problem clearly. I'm there to help you. I'm there to help you. And please visit my classes unacademy.com/DevaGateCSE, and you can catch me on any class and you can ask me the doubt when I'm free or at the end of the session. And in case you need my referral code, you're always welcome to access or use this referral code to access the free classes or to take the subscription. Okay, this is our Telegram channel, guys, Unacademy Gate CS, and come here and subscribe. So daily links we are going to share, and we are going to share the material you can access. And these are all free YouTube channels from Unacademy. You can share with your friends, and India's top educators are going to come to these free YouTube channels, and they are going to deliver the content, and they're absolutely free, guys. And thank you so much, and please like the session if you are enjoying, and share with your friends in case you need it, and please subscribe. Thank you. Take care.